Hello and welcome back. We're going to work on lesson 3.5 today. And this lesson is all about complex numbers. Complex numbers are essentially created to handle the idea of when we have, we're looking for the zeros of a polynomial and they're not real numbers. They're not crossing the x-axis at all. And so we have imaginary numbers and complex numbers. So that happens when we have a square root of a negative number, right? We can't get a real value for that. And so to take care of that, we have, we're going to let this pure imaginary number I be equal to the square root of a -1. And so that allows us to break apart our square roots so that we have a number that we're going to call an imaginary number. And then we're going to build on that for complex numbers. Okay. And so if we have I equals the square root of a -1, then I squared is going to be the square root of that, the square of that square root of a -1, which makes it a -1. So we're going to use these two properties here. So the first example I want to do is the square root of a -16. So we can break that apart essentially into these two pieces, the square root of a -1 and the square root of 16. And the square root of a -1 is I. We just developed that up here. And the square root of 16 is 4. And we always write the value, the numerical value in front of the letter I. So likewise, the square root of a -64 we can break apart as well. And this becomes 8I. And this works for square roots that are not rational. So we can break this apart and say this is square root of 12 times the square root of a -1. And the square root of 12 is really the square root of 4 times the square root of 3 times the square root of a -1. The square root of 4 is rational, so we can evaluate that. Then we have the square root of 3, which stays as is. It's not, you can't simplify that anymore. And then I. And we always put the I in front of the square root. So it's really 2I, the square root of 3. My next example really should have been the square root of this fraction, -9/4. So we can separate that into the square root of 9/4 times the square root of the -1. And that is 3/2 I. So these are all pure imaginary numbers. Now we're going to build on that. This is something called complex number. Complex number has a real number part to it and then the imaginary part to it. And so number 16, they're asking us to find the real and imaginary parts of the complex number. Well, this only has a real part, so there's no imaginary part, essentially. It's just -3. -17 is similar. There's no real part to it. It's just the imaginary part. So it's really 0 plus a -pi I. Now 21. Well, 16 and 17, they wanted us to write the complex. Yeah, sorry, that's what we wanted. So 21 and 22, we're going to do the same thing. So the 1 is the real part, and then the square root of -5 is going to be written as I, the square root of 5, and that's the imaginary. And then 22, again, the negative piece comes out as an I, so it's I times the square root of 7, because the square root of 7 is irrational. It's not an integer when you take the square root, and a -1. And it actually would have been written a -1 plus I times the square root of 7. We always write the real part first, and then the imaginary part second. So let's go to conjugates. Conjugates of complex numbers. So if we have a plus bi, the conjugate is a minus bi. Just like we had conjugates for when we factor, right? So for instance, the difference of squares, x squared minus 9, factors into conjugates, and those conjugates are x minus 3 and x plus 3. So conjugates have the first term is identical and the last term is opposite sign. So in complex numbers, it's going to be a plus bi and a minus bi. So for 23 through 30, they're asking us to find the complex conjugate of each number. So this is a real number plus 0i. So it's going to just be a negative minus 0i. Which is just really -2. 25, we have I minus 1, which is actually a -1 plus I. So we should remember that. And so this should be a -1 minus I. Then 26, we have, again, we're going to write this with the real part first. So 4 minus 2i. So when we write the conjugate is going to be 4 plus 2i. Then 27, this is all a real number. So there's no imaginary part to it. So it's just going to be 3 plus the square root of 2 minus 0i. Then 29, I squared, we already showed that on the last page, is a -1. And so that's a real, so it's -1 minus 0i. But remember, these are just essentially still just a -1. This is essentially still 3 plus square root of 2 because the 0i goes away. Now 30 is I squared times I, essentially, and I squared is a -1, so it's really a -1 times I. And so the conjugate would be plus I. So let's look at 33. 33 is asking us to find x plus y, x minus y, x times y, and x divided by y. So let's take a minute and I'm going to let you attempt those on your own for a moment. Okay, so let's put this together. So x plus y means that we're going to take a -3 plus 5i plus 2 minus 3i. And of course, we're going to add the real values together. So a -3 plus 2 plus 5i minus 3i. And that simplifies to a -1 plus 2i. Then they ask for x subtracting y, which means we have a -3 plus 5i subtracting the entire complex number of 2 minus 3i. So it's important that we go ahead and distribute that negative through. So we have a -3 plus 5i minus 2 plus 3i. And when we add like terms, we get a -5 as the real part plus 8i as the imaginary part. Then they ask us to find the product. So x times y, so -3 plus 5i times 2 minus 3i. So when we use our FOIL, we get a -6 and a positive 9i, and then a positive 10i, and then a negative 15i squared. We have a couple of things to evaluate. We have to add our like terms. We have a -6 plus 19i, and this I squared is really a -1. So this is a -15 times a -1, which is really a positive 15. So we have one more like term to add, -6 and 15. So this is really 9 plus 19i. And then last but not least is x divided by y. So we have a -3 plus 5i divided by 2 minus 3i. And because I is imaginary, it's like having an irrational in the denominator, a radical in the denominator. So it's similar to that. So we're going to multiply through by the conjugate. So multiplying by the conjugate, when we do the FOIL, will eliminate I in the denominator. So remember, we're multiplying these fractions. So the denominator is 4 minus 6i plus 6i minus 9i squared. Those cancel. And this minus 9i squared is really minus 9 times a -1. So it's really 4 plus 9, so 13 in the denominator. Then in the numerator, we FOIL and we get a -6 and -9i and plus 10i plus 15i squared. So we have a -6 plus I when we combine our like terms. And then this plus 15 is times a -1. So it's really a minus 15. So when we combine our real values on top, in the numerator, we have a -21 plus I all over 13. Wow. Make sure you're distributing your negative through, and make sure when you use your FOIL, the I squared turns into a -1. So next up is 38. 38 is similar. They're asking us to do x plus y is 1/2 minus 2i plus 1/3 minus 2/5 I. So getting common denominators, this is like 3, 6 minus 2i plus 4, 6 no, 2, 6. So 3, 6 plus 2, 6 minus 2/5 I. So adding the real parts together, we have 5, 6, and then we have minus 2 and 2/5 I. Fractions are challenging. X minus y, so 1/2 minus 2i, subtracting 1/3 minus 2/5 I. Okay, so we have to distribute that through. So we have 1/2 minus 2i minus the 1/3 we got. Actually, let's turn this into the common denominator of 3/6 again. And then we're going to distribute. So it's a negative 2/6 and then a positive 2/5 I. So when we combine our real portions, we really only have 1/6 and then a negative 2 and a positive 2/5 is 1. It leaves a negative 1 and 3/5 I. And then they wanted us to multiply by the product. It's 1/2 minus 2i times 1/3 minus 2/5 I. So we have 1/6 minus 2/10 I minus 2/3 I plus 4/5 I squared. So i's in the middle. We need a common denominator. So let's do it over here. So 10 is 30 is going to be the common denominator. So 1/6 minus 6/30 because 10 goes into 30 3 times. I minus 20/30 I plus we could get them all the 30th. So this would be 5/30 out here, the 1/6. And then this would be 24/30 I squared. So now we can combine our imaginary parts. So 5/30 and then minus 26/30 I. And then 24/30 I squared, the I squared turns into a negative, so it makes it negative 24/30. And since we made the I squared a negative, we can now have our real portions have combined terms to make a negative 19/30 minus 26/30 I. And we have x divided by y. X divided by y. So we have x, which is 1/2 minus 2i over 1/3 minus 2/5 I. You have to multiply by the conjugate. So 1/3 plus 2/5 I over 1/3 plus 2/5 I. And now we can multiply them. So in the numerator, we get 1/6 plus 2/10 I minus 2/3 I minus 4/5 I squared. So essentially what we got up here, right? Because that's when we did multiply them. So we'll know that's what that simplifies. And then on bottom, when we do this, we get 1/9. And then we get minus 2/15 I plus 2/15 I. Those, the middle terms cancel out because that's what conjugates do. And then we have minus 4/25 I squared. And that negative 4/25 I squared turns into a positive 4/25 because of the I squared. So we have the numerator is what the product of x and y turns out to be, a negative 19/30 minus 26I over 30 all over this 1/9 plus the 4/25. And so our common denominator is multiply them together. So 25 times 9 is 225. So this would be 25/9 plus 36, no, 25, not 9, but 25 2/25 over 30 plus 36 2/25. You can't see. Okay, so we have negative 19/30. This problem is really long. Minus 26I over 30 all over our common denominator. So we can add our numerator. So we get 61 over 225. And you could leave it like this for me, or you can multiply by the reciprocal. So negative 19/30 minus 26I over 30 times the reciprocal of 225 over 61. Okay, so if we do this distribution, it's going to end up being a negative 275 over 1830 minus 5850 I over the 1830. So many fractions involved. Wow. So 48 says, use the definition of I to solve the equation. So this is really why we have complex numbers, because we want to solve equations. So if we want to solve this x squared, it's isolated. So we can divide both sides by 5 and we get a negative 12. And then we are right back to what we did on the first page. The square root of a negative 12 can be simplified into 2I the square root of 3. Because we're going to end up taking the square root to solve for x. And so x is going to be 2I the square root of 3. Can't forget plus or minus, because the square root could be plus or minus on this 3. Okay, let's look at 53. 53 is 53 says, compute the zeros of each quadratic function. So we want to find the zeros. So we're going to set this equal to 0. We're going to set that equal to 0. And so we're going to get that x to the 9 to the other side. 2x squared equals a negative 9, and divide by 2. And then we're going to take the square root of both sides. So this becomes x equals plus or minus the square root of a negative 9 halves. And then we've got two things. We can write this plus or minus the square root of negative 1 and the square root of 9 halves. And this square root of 9 halves can be, we have to multiply by the square root of 2 over the square root of 2 to rationalize this. That'll become the square root of 18 over 2. So this is going to become x equals plus or minus the I times the square root of 18 over 2. Number 58. Okay, now we have this 3-term. So we can see if we can factor this, but we cannot because there's no factors of 11 or 22 that add to make a negative 2. So that's not a possibility. So we're going to use our quadratic formula, which we have not used in a long time. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So ours is going to be x equals the opposite of b, so 2 plus or minus the square root of a negative 2 squared minus 4 times a times c all over 2 times a. So 2 plus or minus the square root of, so that becomes 4 plus 4 times 2 is 8 times 11 is 88. Over a negative 4. Okay. So this is going to be 2 plus or minus the square root of 92 over a negative 4. And then you could simplify this 92 further. Now, if you were to get a square root of a negative number, then you would have to use imaginary numbers. So let's look at 62. So there's no factors of 62. So there's no factors of 5 that I could factor. So I'm going to have to use the quadratic formula again. So we're going to say the x is equal to the opposite of b, so a negative 1 plus or minus the square root of b squared minus 4 times a, which is a negative 1, times c, which is a negative 5, all over 2 times a, which is a negative 1. So 1 and then a -4 times a -1 is a +4 times a -5 is a -20 over a -2. So it becomes a negative square root of a -19 over a -2. Okay. So these negatives cancel. So that's a 1 plus, and then the square root of a -19 can be an I times the square root of 19 because 19 is irrational over 2. So sometimes you're going to have to use the quadratic formula. That gets exciting. So the very last problem I have for this lesson on complex numbers, we learned a lot about complex numbers today, is number 64. And again, it's asking us to find the zeros. If we have to use sometimes we might have to use the quadratic equation. So, I don't. Oh, maybe we can factor this. Let's see if we can factor this. I'm just looking at this for fun here. So a -1 has to be a positive and a negative, but this has to be a +3. So let's see if we made this the -1 and this the +1. This is the negative. I just want to make sure you know that. So we get a negative times a negative is a +2, +1 is the +3 in the middle. And then this is a -1. So I think that works. And then a -2x plus 1 equals 0, or x minus 1 equals 0. And so find out solutions of the quadratic equation. Did I write this down correctly? Okay. So we're going to solve for x here. So x is equal to 1/2, or x is equal to 1. So both of those turn out to be real answers. Real numbers is what I'm saying. So take a deep breath. That was a long lesson, but I'm really going to be assessing you mainly over finding the zeros. So like problems 53 through 60, those would be good ones to really focus on for the exam, for the first test that's coming up in about a week. Catch me back for the next lesson.